So the last thing that we need to do for a quantitative variable, at least for one quantitative variable that we did for a categorical variable, is talking about determining sample size. So just as we did with the categorical variable, especially when we started talking about confidence intervals, and we talked about the width of the interval being important, we started wanting to talk about sample size, because sample size plays a role in how wide our interval is. So first is a reminder as to why the width of an interval was actually important. So what we talked about is that we generally liked narrower intervals, and we liked narrower intervals because they are more informative. So it much narrows down what my actual value I think is, and so I have much more information. So if I come back and say that the mean exam score is between a 60 and an 80, versus if I come back and say that the mean exam score is between a 73 and a 75, that narrower interval gives me much more information about what that mean really is. So we like to have narrower intervals. And one of the reasons we talked about that was the larger our sample, the more narrow our interval was. Now, the thing is, we don't want to take a gigantic sample size if it's not going to happen, because, right, getting data sometimes costs time and money. So what we're going to do is work with the idea of this margin of error. So when we looked at our formula before, I'm rolling back here, that margin of error that we have is this t times s over the square root of n. That's how far off we thought we were when we were working this problem. So this t times s over the square root of n. So the idea here is to take this idea and solve it for n again. But you're going to see a couple of different letters in the formula. We're talking about why they show up. So what I'm going to find is that my n needs to be at least as big as z times sigma over my margin of error all squared. Now think about what these things are. So z, how we found that for was based upon our confidence level. So to find z, if we're going to be 95% confident versus 99% confident, that's going to help us find our z just as it did before. That margin of error is sort of how close we needed to be. How far off are we willing to be? The one that we need to talk about here is this sigma, and as it says here, we have to know it. Which, if you think about what we've done up to this point in this set of notes, sort of seems like a problem. Right, that third condition, when I did both a hypothesis test and a confidence interval, was that sigma was unknown. That's sort of our biggest problem. So the first thing we have to do is realize that. So with our first note, we must have something for sigma. And there's a couple different ways I might be able to get at that. The first one, I might have a sample standard deviation from a previous similar study. Or I'm going to have to ballpark it. And the reason why I point this part out is, unlike when we had a categorical variable and we had an OP hat, there was sort of like, here's the number that we use if we don't have anything else. There is no number to use here if you don't have anything else. You have to have an idea of what to use for a sigma. So either you can use that based upon a previous similar study, or like a smaller study, maybe take a sample of 10 and use that as your ballpark. Or you need to come up with a way of ballparking that number. But you have to have an idea of what that is. And again, what will we do if we're unsure? We'll have a tendency to make that number a little bit larger if we're unsure about it. The other thing that's a little weird in this formula is this idea of z being in here, because in this set of notes we've also been talking about we don't know sigma, so we can't use z. Now z is showing back up. So the good news is if our sample turns out to be at least 60, we don't really need to worry about this. Now the question may be, why don't I just use t there? So let's talk about where t came from. So we pulled up this table, and this is what we used. So the two different things that we needed to know for it was how confident we were going to be, But then we also needed to know this degrees of freedom. And what was degrees of freedom? Well, the degrees of freedom was n minus 1. Now you see the problem, right? I'm trying to find my sample size, so I don't really know what degrees of freedom I can use. So we're going to still use z here because we don't know n. And as long as our sample turns out to be at least 60, there's really no worry about doing that replacement that we have. Alright, so let's take this idea and do a couple of examples. So our example 4. Pizza Hut wants to estimate the mean number of pizzas it sells each day. So they believe this varies with a standard deviation of 65 pizzas. Again, notice I have to have an idea of what that number is going to be. We want to figure out how many days we should sample to be sure that we're within 16 pizzas with 99% confidence. So that 99% is going to help me find my z. Been a little while since we've done this, since we've been using t primarily. So remember, we will draw our picture, put how confident we are in the middle, split that other 1% up on either side here. Go to the table, looking for our 0.9950, because remember it was everything to the left of our question mark here, so I had to add my two little pieces together. Find the closest thing we can in the table, giving us a z of 2.58. Once we have that, we have all of the numbers to plug in. So our n has to be at least as big as our z times our standard deviation over the margin of error that we're willing to have, all squared. And that's probably the easiest thing for students to miss is the squared part there. Doing the math here, we get 109.86. Remember, just before, if I have to sample part of it, I have to sample all of it. So no matter what here, we're going to round up to 110 days. So we will need to sample at least 110 days. Example 5, similar idea. So Old Navy wants to estimate the mean amount of sales they have in a week. This believes it varies with a standard deviation of $4,500. So again, have to have an idea of that. How many weeks should they sample to be ensured that they're within $1,000 with 95% confidence? So that's going to again help me find my z. So again, how confident we are goes in the middle. That other 5% gets split into 2. Whole picture should add up to 100%. We're going to go to the table looking for 0.9750, because that's that 0.95 plus that 0.025. So we've got to add them together. This is one that we did find perfectly in the table. And that would give us a z of 1.96. And then we have everything to plug into our formula. So our n has to be at least as big as this time, as our z is 1.96. Our standard deviation was estimated to be $4,500. The margin of error that we don't want to be more than $1,000 off. And then we square, giving us 77.79 weeks here. But again, want to round that up to 78 weeks. So we need a sample at least 78 weeks. Again, so we kind of focus on the math, but how this is really practical again. And so like now Old Navy is going to stop and think, okay, can I take the time to sample 78 weeks? Is that going to cost me too much time and too much money? Now, assuming they can go back to, past sales, they're probably fine in finding 78 different weeks that they have sales for. Obviously, if this was brand new and they had to wait 78 weeks to get their answer, that's a year and a half. I don't think they want to wait that long to find out their answer. So again, there might be things that we'd have to compromise on. So how can I get my sample size to be a smaller number? Well, there are two different things that I can control. I can't really control my standard deviation. That's pretty much a fixed number. The other two numbers I could change is my margin of error or my z. If I want to make this smaller, I can make my margin of error bigger. So if I'm willing to be off more, then I won't have to sample as many weeks. The other thing that we can do is change our z. Remember, the z was based upon the confidence level. So I would want this number to be smaller. How do I make that number smaller? Well, I actually have to be less confident. So instead of being 95% confident, maybe I'd lower it down to be a 90% confident instead. So that's where the goal is to figure out, can I actually do this now? And if so, great, let's do it. But if not, there's kind of things I would have to talk about of where am I willing to compromise? Am I willing to be less confident in my answer, or am I willing to be off by more? So in class next time, we'll do an example with questions that you have about things. So come prepared with questions that you may have before taking your quiz.